OCR and other legacy document processing solutions have been around for a long time, but they're often expensive, time-consuming to use. Today, we are here to talk to you about Amazon Textract, a machine learning service that is being used by consumers across the world to extract data from their documents. My name is Navneet, and I'm a senior product manager with the Amazon Textract team. Today, I'm joined by my colleague Martin, who you'll meet a bit later, and he will walk you through a live demo of how you can actually process real-life documents through Amazon Textract. The agenda for today is fourfold. First, we're going to do a brief introduction about AI ML services at AWS and where Amazon Textract fits into all of this. Then, we'll talk a bit about the issues with legacy document processing solutions. Following this, we'll introduce you to Amazon Textract's available capabilities and how it actually solves these legacy document processing issues. And finally, like I promised, Martin's going to do a demo where he's going to actually show you in real life how you can use Amazon Textract to scale your document processing workflows. At AWS, we have the broadest and the deepest set of machine learning capabilities that are built for builders of all levels of expertise. The AI services sit at the top of the stack, and they are designed for developers who are looking to add intelligence to any application. You do not need any machine learning expertise to use these AI services, and Amazon Textract is one of them. Textract is designed so that you can extract printed text, handwriting, and data from literally any document out there. Let's take a step back and understand why documents are so important. The simple answer to this is that documents are a primary business tool across verticals. From finance to insurance to legal to even education, documents are ubiquitous across all industries. Now let's talk a bit about these legacy document processing solutions. Typically, our customers process documents in one of three ways. The first is manual or human review of these documents. This, of course, is really expensive because of high labor costs. It is also really time-consuming and highly error-prone. The second solution out there is OCR solutions, which everyone is familiar with. They've been out there for a long time, but the problem with OCR is that it works best for really simple documents. And the output is usually a bunch of text, which is stripped of any document structure. You do not get to see lines, other structural information like key value pairs, or even tabular information. So to actually infer information from the extracted data and create value, you need to build costly post-processing code on top of OCR solutions. The third methodology or solution that customers typically use is rules-based or template-based processing. The issue with this approach also is that it's only as good as the base OCR technology that you've built this approach on, firstly. And also, secondly, it's not a really scalable solution. As you onboard new document types and formats and versions, you need to constantly go back and invest manual effort in refreshing these templates and adding new templates, which is not at all scalable. This is where Amazon Textract comes in. Amazon Textract is a machine learning service that uses computer vision, NLP, and other machine learning innovations that we have built to extract printed text, handwriting, and structural data from virtually any document that's out there. So what it does is that it goes beyond basic OCR to actually not only extract text, but structural elements like tabular information or key value pairs from your documents. Like I mentioned, you require no ML expertise or prior machine learning experience to use this. You can easily integrate into one of our globally available managed APIs. So what that means is that you can quickly reduce the amount of manual effort in your document processing workflows and reduce your cost base in the process. Okay, now we've heard about what Amazon Textract is. Let's talk a bit about customers who are actually using this. What we've found is that customers across verticals, right from financial services to healthcare to manufacturing to even public sector, are already actively using Amazon Textract. And this, in turn, is driving 3 business outcomes for them. The first is productivity. So their workforce is way more productive because they're no longer spending their time extracting data from documents and instead utilizing that time making business decisions. The second is end user experience. So because they're able to extract data quickly, now they're able to deliver a superior customer experience. That could mean being able to process a loan and issue a loan quicker, or even adjudicate an insurance claim much faster. And finally, it results in better decision making, because now you have a lot more data and a lot more accurate data, and that typically means better decision making. Let's look at a few real-life examples from our customers. The first one here is Black Knight. Black Knight is one of the biggest names when it comes to software, data, and analytics in mortgages. They have a product called Underwriter Assist, UA, which is an AI-powered mortgage solution. They integrated Textract into the solution to automate data extraction for a whole host of mortgage-related documents. With this, they've been able to do 3 things. A, they've been able to increase the productivity of their lenders, who are now actually spending time making lending decisions. B, they have reduced costs. And C, in the process, they've actually improved their customer satisfaction scores. It's a similar story when you look at Anthem. Anthem is one of the largest health insurance providers in the US, serving more than 45 million members in the US alone. Now, they actually utilize Textract to extract information from all of their insurance claims-related documents. With the help of Textract, they have been able to process now more than thousands of documents in a day. And this has basically led to an automation level of almost 80% in their claims processing workflow. In fact, they expect to get to over 90% on AWS pretty soon. This slide over here that you see it's a representative slide. It's not meant to be a laundry list, but just shows some of the customers that are using Textract. You can see over here the wide variety of customers and industries that are already using Textract to automate their document processing workflows. OK, now let's dive a bit deeper into the generally available features at Textract. You might be familiar with Textract's OCR or text extraction, but like I said, Textract goes way beyond that. We are able to extract handwriting data, as well as structured elements like key value pairs in a document, as well as any information that is structured in the form of tables. We have gone beyond that recently based on customer feedback and launched 2 new APIs, the Analyze Expense and Analyze ID API. These are designed to extract information from specialized documents like invoices and receipts and ID documents. And recently, we also launched the really powerful feature called Queries, where you can actually ask natural language questions and extract the information that you're really looking for from your documents in question-answer pairs. We'll now spend some time looking at each of these features, the use cases it serves, the kind of output that you can actually receive, and the value it creates for our customers. Let's start with text extraction. So the value prop here is that Textract has industry-leading OCR accuracy, which you can bring to your documents. This is typically used for really dense documents with a lot of text. Think like legal documents. The output that Textract provides here is 3 hierarchies of information: the page, the line, and the words within a line. And with each of the lines and words, you also get a visual bounding box or geometry information, as well as confidence scores that Textract feels as it extracts this information. Going to the next feature, table extraction. This is really useful when you have a lot of structured documents which have a lot of tabular information. Think financial reports or even medical records for that matter. What Textract does over here is that it extracts all the tables within a page, the cells within each of these individual tables, as well as all the words within a cell. And it's able to provide the hierarchy or the relationships across each of these elements on the page. In addition to this, you also get geometry information or a bounding box of each and every table, and the confidence score associated with it. It's a similar story when it comes to form extraction. In a lot of documents, you would have noticed that information is present in the form of key value pairs. Think of like name, John, address, or even like date of birth. All of this is information that is structured in the form of key value pairs. And this is really important for our customers in their downstream systems because that context is useful in their downstream systems as they analyze that data. So what Textract does is it automatically identifies which of the information on the page that you're processing is structured in the form of these key value pairs, and it's able to extract each of these keys and values and link them together and provide them to you. Similar to our previous features, each of these key value pairs, again, comes with a visual geometry box so that you can easily locate where exactly the keys and values are on the page, as well as confidence scores associated with each of these. Now, moving on to the next feature. Like I said, we have recently forayed into specialized documents. The first one is invoices and receipts. These are documents that most customers process as part of their accounts payables, their accounts receivables, or even expense management functions. The complication with these documents is that there is no set structure for an invoice or receipt. Every customer or every company has one or even hundreds of different designs or structures for an invoice. Just even look at the document on the slide over here, the Whole Foods receipt. This could differ really from one company to the other. A Target receipt would look different from a Whole Foods receipt, would look different from a Macy's receipt. So, and this becomes really complicated for traditional solutions because they use a template-based approach, and that approach does not scale. As a customer encounters receipts or invoices of a different design or a different structure, they need to go back and ensure that their template database is updated with the respective templates. Otherwise, the data extraction pipeline essentially breaks. Amazon Textract uses machine learning to solve this problem. You do not require any templates or any pre-configuration. You just drop in the invoices or receipts that you want to process, and it's automatically able to extract a plethora of information. Even on this receipt, you can see a bunch of information getting extracted, like line item details, like the pizza slice and the price, but also totals, subtotals, and other important fields like the vendor name. It's really curious. This is a really difficult problem which we are using machine learning to solve. If you zoom into this image over here, you will notice that there is no identifier for vendor name or a specific key labeled saying that Whole Foods is the vendor. But Amazon Textract is able to use machine learning to automatically identify that that Whole Foods is actually a vendor and associate that as the vendor name. The other really valuable feature of this API is that the output has normalized keys. What I mean by that is, irrespective of which receipt you process, you will get a consistent set of key names like vendor name, subtotal, line item, price. So when you process a diverse set of invoices or receipts, you are able to get consistent key value output so that you can put this into a database and run analytics across your set of invoices or receipts later. Moving on to the next feature, identity documents. These are really relevant for use cases like ID verification, online registration, or billing. And here the challenge is similar to invoices and receipts. If you look at a typical ID document, it varies in format by country, by state, or even by other parameters like the age of the person. So a typical rule-based or template-based approach does not scale, again, because you need to constantly update your template library with the different templates, otherwise, which is a lot of manual work. Now, again here, our Analyze ID API uses machine learning to extract all the important fields that are relevant for the document. Analyze ID is able to extract information with very high accuracy, real time, from passports, driver's licenses, and state IDs across the US states. And the output here too comes in the form of normalized keys and values, so that even when you're processing documents from diverse countries, states, and even cities, you're able to put all of this information into a database for you to search through and analyze later. And as I mentioned, none of this is template-based. You don't require any templates or pre-configuration. You just drop in your documents, and it automatically is able to extract this. Finally, our latest feature, queries. So this feature is basically designed to give customers the flexibility to actually request for the information they need from a document. So if you take a typical mortgage customer, they already know what information they're looking for from a given mortgage document. It could be the borrower's date of birth, or the borrower's SSN, or the borrower's address. They have a list of 5, 10, 15 fields that they want to extract from the information. Currently, when they process a given document through OCR or any other solution, they have to write post-processing code to actually pass through this output and find the information that they're looking for. You no longer need to do that. With Amazon Textract queries, you can just ask for the information you require in the form of natural language questions. And the output is basically exactly the information that you're looking for in question-answer pairs. What Amazon Textract is doing at the back end is it's combining visual, spatial, and the textual cues from the questions that you're asking to extract this information with really high accuracy. And because you are provided this information in exact question-answer pairs, you do not need any of the post-processing you used to do before to extract this information. Let's look at a few examples of this. This is a typical pay stub. Here on a pay stub, you could be looking for multiple pieces of information. Let's say you're looking for the gross pay year to date, or the gross pay this period for this person. Typically, you would have to run this through OCR, then find where in the page this information is there, which is typically a table structure, then try to triangulate the row ID and the column ID, and then go based on that and extract this information. This is costly, document-specific, custom post-processing code that you would have to build on top of your OCR solution. You no longer need to do that. You just simply ask the question, what is the gross pay this period? And queries is automatically able to identify where it is in the document and extract that and give you the answer, $452.43 in this case. Let's look at another example. In a loan application, typically you have identically labeled fields. In this case, date of birth. Let's look at date of birth. These are identically labeled fields in two sections. One is the borrower section, and another is the co-borrower section. So if you are interested in actually just the borrower's date of birth, again, you would have to parse the output that your OCR provider provides, and you would have to figure out based on geometry whether that word or that field is near the borrower section or the co-borrower section, and you would have to do all of this yourself. You no longer need to do that. You can just ask a question, what is the borrower's date of birth? And it's able to extract that and find the right one, 1/1/1900 in this case. Let's look at one more example. Here's a typical health insurance card. Now, if you look at this card and zoom in, you see that this is a health insurance provided by this company, anyinsurance.co. The plan here is any plan X EPO. The reason I know this is because as a human, I've seen multiple examples of this, and I can tell you that the text on the top is the company and the one at the bottom is the plan. But it's not really labeled there in any form. Amazon Textract is able to identify these implied fields automatically. You can just ask what is the member name, or what is the plan type, or who is the insurance provider, and it's able to get this information automatically on its own. These are just a few examples, but I actually want to bring in my colleague Martin, as I promised, who's going to dive into each of these in depth and show you a real example of how customers are using these features.
No, thank you. There we go. Okay. Cool. Let me show you how you actually get to Textract and how you can try it out. You log into the console, and then you can search for Textract in the search box and just click on it, and that's how you get to Textract. And in order to try it out, just click on Try Textract. We have the other services as well available there, but we'll focus on Analyze Document for now. So this sample is a sample vaccination card. You can see that forms did identify some key value pairs, and also tables did identify the table. But what we can see is that the values in the table are not lined up with the column structure, actually. So the date, for example, is not under the date column. So in order to process this and extract the information, it would be pretty hard to do that. Now, when we use queries, though, we can see that it did actually extract the lot number correctly and also the manufacturer, even though they are switched. And we can also search for the, let's take the date for the second one, which is not in line. So once we submit this, we can see that it did actually find the correct date, even though it's not under the date column, which is much easier than just parsing through the table. Let's try out another question. What is the number? Or what is the date of the first dose? Or the lot number of the second dose? We can see that it finds it as well there, even though the lot number and the manufacturer name are switched. Obviously, we can get the date of the first dose as well. There we go. That's the date of the first dose. And this way, query makes it much easier to extract information, even when the document is not well formatted or structured. Let's look at pay stubs as the second option to extract information on. Pay stubs is a hard format because there's a huge variety of different formats for pay stubs. We can see that tables did in fact identify the table structure, and we can also see that there's one, the gross pay is identified as a merged cell, so it spans multiple columns. And we can see also that we do have the information about the year-to-date gross pay. But in order to extract that information, we would have to parse through the table, understand the structure. And the structure is not the same across all pay stubs. So when we use queries, we can get to that information just by asking the question. And this will work across multiple different formats. You can also see YTD was used instead of year-to-date, which is actually on the document. So queries does have a notion of like synonyms. It's a little more powerful. So you see the different questions that we suggest for this pay stub, but you can also just enter your own question and try that out. Like in this sample, we're not using one of the questions that we suggest there, but we all want to know the social security number. And we can get that just by asking the question. One feature as well is also you can add an alias to the query, the question that you submit. And that alias will also be part of the response. So that makes it easier for you to match the value that you receive with the label that you use internally. Because you don't have to search for the question that you passed in. You can just use the alias and obviously use the same alias that you use internally for that information. And once again, this works across a huge variety of different pay stubs formats. It's not bound to a specific format. But let's look at a loan application. A loan application is well structured. It's a form type, so you can see that there are a lot of key value pairs identified on this specific example. And you can see that we find the key value pairs. We support selected, not selected, checkboxes. We can also see that we get the values for, let's say, the amount or the interest rate. And you can see like a lot of different key value pairs were identified, which is just using the forms model. So this is what you get with the out of the box, just using the forms model. No tables in this one, but you can see that there's a borrower section and a co-borrower section, and they share the same key. Like Nav mentioned earlier, This one has the same key, social security number, as we can see when we click on this as well. So one is social security number NA, so there's no value in there. And the other one being social security number with a number in there. And when you process this, you would have to identify, based on geometry or other factors, to which this belongs. Similar to like the name of the borrower or the name of the co-borrower. They are in the different sections of the document belonging to the co-borrower or borrower. With queries, we can just ask for this information with the context passed in. So we ask, what is the borrower's SSN? And once again, we use SSN. On the document itself says social security number. We don't need to be accurate when it comes to like that. So there's, it takes this information based on the context. When we pass this information, borrower SSN or co-borrower's SSN, so when we give it context, we receive the correct value. So no processing required, no figuring out like where in this document is this information. We just pass this into queries and it makes the right decision on getting the correct value. What's also interesting with queries is that you can ask for specific information based on checkboxes. So in this one, we want to validate if the conventional was selected, and we can just ask that question. So we pass in this question together with our document, and in this case, correctly get the response, yes, it is actually selected. To double check, we'll look at like a negative example and validate if VA was selected, and hopefully the answer is no. And yep, correct, it's no. So we can see that it correctly identified this. We will also be able to query or ask what the value is for a specific data type based on the select box. Like here, we are just checking what's the purpose of the loan, and the answer is the value that is next to the select box, in this case purchase, which obviously makes it easy as well to get the information, extract the information that you want from the document. Once again, you can pass on an alias, map it to whatever your internal representation is there. Let's pick one sample where it's unstructured with dense text and see how queries does in that case. Because this would not be a fit for forms, or not be a fit for, at least not for most of the values, for tables. So there's no table in there. Forms would identify like the date, the city, state, property address, but to get to the loan amount, the principal, we would have to parse the text, annotate the text, probably use named entity recognition. With queries, we can just ask for this information. Also, we are interested in what's the initial monthly payment. We have multiple dates in this sample. So we want to know what's the beginning date and what's the yearly interest rate. And we also want to know when the maturity date is for the loan. And obviously you can ask more questions. So let's try these. And we expect the values to be like in the text. So even a human would probably take some time to find this information, because you have to understand the text, parse the text. And the monthly payment is down there. Beginning date of the payment is that. Yearly interest rate, 4.15. And maturity date is April 2032. Let's check these. can see the OCR did identify all the text, and queries did also find the values. There we go, the loan number, the monthly payment, beginning date. So queries did not get confused with the dates. It found the correct date for our question. Okay, so Textract queries works with structured, semi-structured, unstructured documents, and using the console is an easy way to check or quickly validate if it works. One more sample, specifically for remorse. I took my badge, I took a photo of the badge, and there's not much information on it, but especially there's no key value pair, so there's nothing on my badge that identifies that this is my name, or this is the company that I work for, or whether or not I'm an employee. But when I ask this question, we can receive the results through the implied keys, as Nav mentioned earlier. So you can see it identified that Martin Schad is the name on this document, AWS is the company, and it even identified that I'm an employee because it says it at the bottom of this. So the console is a great way to try out Textract, check if it works, but in order to run it at scale, we will publish a solution like this, which is a CloudFormation template that spins up an entire infrastructure, and it allows you to run Textract on step functions and with comprehend. So customers rarely use Textract on its own, but in conjunction with other services. Like here, step function is a great way to model workflows. Here's the workflow that I designed for this, where you essentially pass in a document, it gets classified, and then we run logic based on the classification result. So in the beginning, we will just have some pre-processing of the document, basically identify if this document format is supported, how many pages it has. This section calls Textract and generates a text file, which we then use with Amazon Comprehend, which does provide text classification feature. And the output of that classification will then be used to route the document to the subsequent processing. So here, if we go to the left-hand side, then it was identified as either a pay stub or a W-2. And then we run Textract with the queries feature, and in the case of W-2, with a forms plus queries feature. And then we generate a CSV, and we pass that CSV into a database. The other output options are either there's a limit on how many queries you can pass in one go. That's one exception. Or the other one is, if it's a document that was identified as text, then we submit it to OpenSearch, or we don't know what to do with the document. So let's take a look and see what the processing actually looks like. Based on the first document, which is, I just call it blah because it's a nonsensical text, which this process does not know what to do with. So this document actually just contains the word blah, 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 blah again and again and again. So we don't know what to do with it. So we expect this process to send it just to don't do anything further with that. In order to kick it off, we just upload it to a specific S3 bucket with a prefix, which then kicks off this entire process. And we see it's running. Let's look at the state. And we can see it passed the pre-processing, and now Textract's doing its work. It finished. Now we are classifying this document, and the classification did yield to this document not getting submitted to Elasticsearch or to the database. And we can see the document type is none. Therefore, we didn't understand this document. We didn't know what to do with it. So we just discarded it. Let's look at another sample where we do have text information, like this one, just the lorem ipsum stuff. And this should be identified as AWS Other and then submitted to OpenSearch. So let's upload this document and take a look. There we get to the process list. This one is running, the other one succeeded. Once again, we call Textract just with pure text. This one got classified as AWS Other. That's the name I gave it when I did the training of the classification model. And it got submitted to OpenSearch. Okay, so this works nicely. Let's look at a document where we actually do submit data to the database. So this is the database, and when we look at it, it's empty right now. Makes sense because the other two documents were not submitted to the database. But let's take a pay stub, upload it, and then see what the process does for this one. And here we are looking at the pay stub, and the information that we could check are like the gross pay for this period and the year to date. Okay, let's upload this document, and obviously should trigger the same step function process. There we go. Textract first does pure text detection, and then we do the classification. And based on the classification, it was sent to the process that enriches it with the specific questions or queries for pay stubs. So you can see what is the pay period start date, for example, and like all the other information that we want to extract from this. And by the way, all these are components that we will publish that will make it easy for you to basically design your own flow. So when we now look at the database and query it, we will see that all the information from the document was actually submitted to the database. So here we find the 770 and the 2310. And this process obviously works with W2s as well, because we just have a classification model that includes W2s, and we do have a configuration that knows what questions to ask for W2s. So this is easily expandable as well when the classification supports more document types, or we just configure this and you can essentially use the same process. So here we look at the execution for the W2. And once again, Textract is OCR, meaning identifying all the words on the page. And once it returns, we expect the classification to be W2, sent to the enrichment process. Yep, W2. And then we see we have different questions asked now compared to the pay stub, where this one is what's the employer name, for example. Once again, you can see that it got submitted to the Aurora database, to our relational database. And we select, we can see that it not only includes pay stub information, also W2 information, and also W2 information outside of the queries that we submitted, because we also use the forms model for that. And you saw that the W2 has a lot of information. Now we can run this at scale. So in this case, I'm submitting 170 documents to this bucket, which then kick off 170 different step function flows. But obviously, step functions can scale way beyond that, so that's no worry. We see a lot of them running, but we already see a lot of them succeeding as well, meaning the entire process already already finished. So we did the OCR, we did the classification, we did the enrichment, we called Textract again, and then we submitted it to the database. When we look at it, there we see the additional pay stubs, W-2s coming in, a lot of information getting extracted from all these documents. And literally within seconds, we got the information that we are looking for. And then subsequently, obviously, we can use that information to drive decisions. Let's just look at the count. So we already have over 1,700. We can see the ones that are still running. And obviously, we can see them finishing and see the count increase in our database. So this process you can pretty much scale. You can throw thousands of documents at this. And it won't budge, won't just process them, submit it to the database. There we go. I think everything is succeeded now. Let's check. There was one running, I think. Let's check. We still see some running. Oh, everything finished. All processes succeeded. Information in the database, total count is more than 5,800 data points were extracted. And that's within like a minute or two. We got all this information extracted at scale from documents, and that was easy. Cool. Now if you want to.
Thank you, Martin. Okay. So as the last slide, we want to just leave you with a few resources that you could use to get started, to familiarize yourself more with Textract, a few blogs to actually see how you could get started, and a few code examples that you can start setting up at your end. Thank you so much for joining today's session. Hopefully this has been helpful in familiarizing yourself with Amazon Textract and to see how you can actually use Textract to automate your document processing workflows. Thank you.